Okay, this is TempleOS 5-minute random code walkthrough, episode 67, and I'm your host, Terry Davis. And it looks like we are in the math library inside of in the Atom directory, math. Is that where it is? No, that's not where it is. Oh, it's in the graphics. Inside the graphics, math graphics. Okay. So this is the circle routine, and I'll tell you how it works. It uses scaled integer math. So you can imagine that as, well, let's suppose, we, just to show what scaled integer math is like, well, let's suppose we okay, so look at this. I stepped by 80, and if we break this up, if you can imagine, this is a decimal place. Okay, do you see how that's going by a half? Well, that's the way fixed point math works. So floating point is different. Anyway, so for these operations, we scale by 24 bits, it looks like. So 24 bits is, you can imagine, a couple less than 32. Anyway, so it's something like that. Now what do? I find the sine in the cosine of t, 1 over the radius. Well, so let's see. Let's think about this. If we're drawing a circle, it's 2 pi r is the circumference, and if we want to step by by 1 pixel. So let's see. Apparently it's 1 over the radius is the we're rotating by a tiny angle. Let me explain this. How do I explain this? In electrical engineering, you have a magnitude at angle 1. Complex numbers, you say magnitude, and you use an angle symbol. Now, if you imagine complex numbers, and if you multiply these two complex numbers, it equals m1, m2 at angle 1 plus angle 2. Now, what if we what if we define M1 and M2 to be, I guess, the radius. We want M1 equal to the radius and M2 equal to 1.0, and we want the angle to be, so this is a vector notation that I just showed right here, but when you do it as complex numbers, it's x1 plus y1i, x1 plus y1i, or j if you're an electrical engineer, times x2 plus y2i equals, and when we expand this, x1, x2 plus I1, x2 plus y2, x1, I, and then I think we minus y1, y2. So if you do the math, you get complex numbers like this, and so what we're going to do is, let me draw this. We have a vector, and we're going to rotate by, we want 1 pixel rotated, and then we're going to keep rotating the result, and we're going to go around in a circle. Okay, so the total distance is going to be, anyway, so the circumference is, anyway, okay, so what do? I have to convince myself why this is 1 over r. This is the angle we rotate. R, the radius. Okay. Well, anyway, so we scaled the, remember we talked about scaled arithmetic. We rotate by an angle of 1 over r radians, and we have 2 values. We have if step is greater or less than 0. Anyway, so we start at a distance of we get the x and y at an initial position on the circle edge, and then we go through one length, which is radians times radius. Okay, so this is 2 pi r is the length, and each time we step 1 over r radians, which I guess is 1 pixel. That's 1 pixel, I guess. And then we do this cosine. Okay, so this angle is oh, you know what? I think we want the other. We want cosine x plus I sine x. So this is the multiplied by. Okay. Well, anyway, that's oh shucks. Cosine, we have plus and minus, and this is using fixed point arithmetic. So the new x is cosine. So the new x is this value and this value. The new y is this value and this value. And I'm not explaining this very well, am I? Okay. First we get x and y to be, we have x plus iy, and then we multiply by the angle we want to rotate, multiplied by this, and that yields cosine x minus I sine y. That's minus sine minus sine y. So that's what that yields. Cosine plus, and then we do the cross between these. So sine x plus cosine y. Let's see if I did it right. So cosine x minus sine y. Okay, S1 is negative, so that's the sine. In order to prevent having to calculate the negative repeatedly, I made a positive and a negative. So sine 1y. Cosine x minus plus sine 1y, and sine x cosine y. So that's what we're doing.